Imagine this. You have survived the apocalypse, but you still have to eat your veggies. There are no grocery stores, so you must grow your own, and you must provide your own fertilizer.
In this video, I conduct a 7-week science experiment to test diluted human urine against other natural fertilizers for leafy green vegetables, including animal poop and fish-based fertilizers.
All right, let's do it.
So, can diluted human urine be used as a successful alternative to other natural fertilizers for leafy greens?
Leafy green vegetables require high amounts of nitrogen to grow. Urine is high in nitrogen and has been used for a millennia as a plant fertilizer. To fit my apocalyptic theme, I have 2 main rules. First, I can only use fertilization methods that I might be able to obtain and use in the event of an apocalypse or other major disaster.
This will include pea, rabbit poop, bat poop, or guano, fish, and fish emulsion.
And 2, I must control for external variables to get a reliable result.
Most of my urine research came from the Rich Earth Institute's publication, Urine, My Garden, which details guidelines on using urine as a fertilizer for home gardeners. This publication cites 2006 guidelines from the World Health Organization that states that urine from a single household can be safely used on home gardens without any pretreatment.
And since my other household members said, "Ew, that's so cringe," I will be the only one eating the veggies grown from this experiment. And so I hypothesize that diluted human urine can be used as a successful alternative to other natural fertilization methods for leafy green vegetables.
I will be using the Purple Lady variety of bok choy as my leafy green vegetable because 1. It matures in only 45 days. 2. In my experiment last year, Purple Lady bok choy seemed to be more hardy than Little Jim lettuce. And 3. You cook it. There are 6 total groups in my experiment, a potting mix only control group and 5 groups using the different natural fertilizers, specifically 2 fish fertilizer-based groups, 2 animal poop fertilizer-based groups, and of course the 1 pea fertilized group. Each group has 3 plants for a total of 18 plants in this study. Both the fish emulsion and diluted urine are quick-release liquid fertilizers that will be added starting at 3 weeks to avoid burning delicate seedlings. The whole fish, bat guano, and rabbit poop are slow-release fertilizers that will be added at planting. The first group in the brown rim pots includes our control group, potting mix only. I used a potting mix to control for the quality of the soil and reduce the risk of insects. The same potting mix was used for all plants in the study.
All fertilizers chosen for this study had to be high in nitrogen and natural so that I might be able to obtain them on my own in the event of an apocalypse.
Fish.
In an apocalyptic situation, I would need to catch fish in whatever way possible, however long that might take me.
Fortunately, as far as I know, we aren't in that situation yet, so I will be purchasing fish for this experiment. Florida woman eaten by alligator while fishing from flamingo float. In the green rim pots are whole fish, specifically anchovies with no salt added as purchased from a local supermarket. Purchasing the fish allows me to better control for the type of fish, size, and amounts. This makes for a more consistent nutrient profile in each of the fish pots. Fish are high in nitrogen and were frequently used by Native Americans as a natural fertilizer. About 3 anchovies were added to the middle of each fish pot.
Since I could not find consistent information on the exact amount needed or the NPK profile of using only fish, I decided to use fish emulsion as well.
Fish emulsion. In the blue rimmed pots is fish emulsion.
There are lots of instructions online for making your own fish emulsion, but I will be purchasing mine to save time.
Fish emulsion is a widely available high-nitrogen liquid fertilizer made out of fermented fish byproducts. And it smells terrible. The instructions on my bottle were not fine-tuned enough to calculate the correct amount per pot, so I had to use instructions from a competing brand. Instructions indicate using 1 tablespoon of fish emulsion per gallon of water per cubic foot of garden soil every 3 weeks. Using the dimensions on the bottom of the pots, I calculated them to be approximately 0.26 cubic foot each. So since the pots are 1/4 of a cubic foot, I would need to use 1/4 of a gallon of the solution every 3 weeks, which is equivalent to 4 cups per pot. I felt this was too much liquid to give the pots all at once, so I instead divided this amount by 3 and gave each pot 1 1/3 cup every week starting at 3 weeks. Bat guano. Next, in the hot pink rimmed pots is bat poop or guano. In Florida, we have a couple of species of tiny little bats which produce a nutrient-rich waste product or poop, also known as guano. In an apocalypse, this would have to be collected fresh from underneath a local or homemade bat house. Also, since bat guano is considered a hot fertilizer, it cannot be used fresh, but should instead be composted for around 6 months prior to use to avoid burning your plants.
For safety and convenience, I will be using a store-purchased bat guano for this experiment.
The box instructs to mix 1 to 2 teaspoons per gallon of soil. I calculated out about 1.7 gallons of soil in my pots and decided to go with 4 teaspoons of bat guano per pot. I mixed half of that amount into the middle of the pot and the remaining half near the top.
Post-editing Elizabeth here. I do realize that this is the internet, and therefore, I would like to point out that I am not predicting, anticipating, or expecting an apocalypse of any sort. It is just a silly theme for an unconventional science experiment. Thank you for watching, and please enjoy the rest of the video.
Rabbit poop. In the purple rimmed pots is a mixture of rabbit poop and potting mix. Among animal poop-based fertilizers, bunny poop is one of the few that is considered cold. This means that it can be used directly out of the animal without any waiting. In an apocalypse, I would have to obtain a bunny by either catching a local one, like this marsh rabbit here, or finding an abandoned pet. However, since it would be irresponsible of me to get a rabbit for a YouTube video, I decided to instead purchase the poop online.
This is 2 pounds of rabbit poop, which is probably one of the weirdest things that I've ever purchased on the internet.
Per vendor instructions, I mixed potting mix with rabbit poop at a 3-to-1 ratio. That means for every 3 scoops of potting mix, I mixed in 1 scoop of rabbit poop. Urine.
It's time to pee the plants. Again.
The plants in the orange rim pots were fertilized with diluted urine. According to the Home Gardener's Guide from the Rich Earth Institute, plants need between 3.5 and 5.5 gallons of urine per 100 square feet of garden space over the plant's entire growing cycle. My pots are a little larger than last year's experiment, so I had to recalculate the amount of urine required. I calculated a surface area based on the diameter of the pot and used the urine requirements from the Rich Earth Institute to calculate how much urine is needed for our pots over the bok choy's entire growing cycle. Then I divided by 3 to get 17 to 27 grams of urine for 3 weekly applications.
I decided to go with 27 grams, since it's a very small amount. and I will be diluting it with water at a 1:10 ratio.
To achieve the 1:10 ratio of urine to water, I started with my 27 grams of urine and added to that 270 grams of water. This yielded about 1 1/4 cups of solution. I fertilized with this solution weekly, starting at 3 weeks old, while my original plan was to only fertilize with the urine solution for weeks 3, 4, and 5. I decided to go ahead and fertilize on week 6 as well for 2 main reasons. First, the plants were doing well, and I thought they could handle it since it was a small amount and highly diluted. And second, since the bok choy will be cooked, I was not concerned that there was only 1 week left until harvest. This fertilization schedule coincided with that of the fish emulsion. For these weeks, all other plant groups received 1 1/4 cups of just water. I am only showing the footage from the first plant of each group for brevity.
To obtain a reliable result, I need to control for all external variables in my experiment.
This year, I decided to add a plant cage as a control. This would prevent our local feral peahen from eating my bok choy. It would also prevent animals such as this mom and baby raccoon from digging through my pots. Stinky fertilizers such as fish and bat guano sometimes attract animals looking for a midnight snack such as raccoons, opossums, and cats. I just kind of winged it on my plant cage design. It was my first time working with chicken wire, and that was interesting. What I ended up with was a crazy zip tie monstrosity of a plant cage that was ugly, but totally functional.
As my second control, I used diatomaceous earth to control for caterpillars and other insects.
Also, all plants receive the same potting mix and pot size, as well as the same amounts of sun, rain, and water. And of course, all plants receive the same winter song for encouragement. And some apocalyptic literature for humility.
The struggle was not against a human enemy or for victory. The struggle for those who survived the day was to survive the next. Despite using diatomaceous earth, I did run into some problems with caterpillars.
While all groups were affected to some extent, the potting mix only and the fish emulsion groups received the most damage. I did my best to pick off the caterpillars when I noticed the damage. However, in the future, the organic pesticide BT would probably be a better choice as a control for insects.
Whether you're talking trumpets or zombies, it's a good idea to know what fertilization options you have during hard times.
Unfortunately, I had a really hard time controlling for caterpillar damage in this study, which tainted the results for both the fish emulsion and potting mix only groups. However, both animal poop groups and the pea plants did quite well, with the bat guano group doing especially spectacular.
A possibility that I had not previously considered is that there might be some variability in seed quality.
This might be subjective, but the first of the pea plants, which came out significantly smaller than the others, appeared stunted even prior to fertilization. And the last of the potting mix-only plants appeared malformed, likely affecting its growth potential. Issues with seed variability would likely only be controlled with a much larger sample size.
About halfway through this experiment, I did realize that I would likely get inconclusive results.
So I reran the experiment 5 weeks later in smaller pots, reducing the amount of fertilizer in proportion to pot size, and controlling for caterpillars by placing all pots inside mesh butterfly cages.
However, I ran into problems here as well.
First, it was too hot for bok choy in Florida by this point, and plant growth was extremely stunted. And second, the rabbit poop pot somehow developed a severe case of the fungus gnats. And since they shared an enclosure with the pea plants, growth for both of these groups was likely affected. Fortunately, none of the other groups were affected by fungus gnats, including the fish emulsion and potting mix only groups. With more reliable results this time for fish emulsion, we can see that it performed on par with only fish, both performing considerably better than potting mix only. In fact, all fertilizer groups did considerably better than the potting mix only group, with the bat guano group again doing the best.
Given the issues with the controls for these studies, I was humbly reminded that we do not live in a vacuum, meaning that it is sometimes really hard to control for the external factors in our experiments. However, both studies taken together, one might conclude that in an apocalypse, one might use any of these high nitrogen fertilizers they have access to.
However, from a practical standpoint,
catching fish requires one to expend energy that might be better preserved for escaping zombies. Plus, it makes far more sense to just eat the fish and use any leftover parts in the garden. While it is possible to make your own fish emulsion, it is a long and stinky process that requires months of fermentation and is likely to attract wild animals. Bat guano makes an amazing fertilizer. But if you were to do it yourself, you would likely have to install a bat house, wait a couple of years for the bats to find it, safely collect the guano, then compost it over several months. Rabbit poop doesn't need composting, and it doesn't require as much time or waiting other than to acquire a rabbit. However, after all that effort to catch a rabbit, doesn't it make more sense to just eat? So that leaves only urine, an easily available, renewable resource that's free and requires minimal effort to obtain. Big Brother is watching you.